Not one mystery hangs over Pluto tonight. 2. The first is why a world this far from the Sun still carries air at all. The second is stranger, because that air should warm a little, yet it keeps throwing heat away. Now James Webb is staring into the dark and catching the thief in the act. If stories like this pull you in, subscribe and stay close. The strangest science is usually hiding at the edge, and I want you here when it breaks. Some of the biggest secrets live where the sunlight is weakest. For a long time, Pluto looked simple from far away. It was just a tiny dot at the edge of the solar system, cold, dim, and easy to ignore. People argued about whether it was even a real planet, but the deeper truth was harder than that. Pluto was never boring. We just did not have the eyes to see how strange it really was. That story starts back in 1930, when a young astronomer named Clyde Tombaugh found Pluto by comparing pictures of the night sky. He was looking for a moving point of light, and there it was, creeping across the stars. For decades, that tiny point became the 9th planet in school books, a lonely world far beyond Neptune. Then, in 2006, Pluto was moved into a new group called Dwarf planets, and many people thought that made it smaller in every way except size. But Pluto does not care what we call it. It is about 1,477 miles wide, which means it is less than 1/5 as wide as Earth, and only about half the width of the United States. It travels around the Sun at an average distance of about 3.7 billion miles, so far away that sunlight needs around 5.5 hours just to reach it. At noon on Pluto, the Sun is only about 1/900th as bright as it is on Earth, more like a fierce star than a warm daytime sun. Even its time feels strange. One day on Pluto lasts about 153 Earth hours, so sunrise and sunset move with painful slowness. 1 year there lasts 248 Earth years, which means a single Pluto season can last longer than many human lifetimes. And hanging beside it is Charon, a moon so large compared with Pluto that the two almost act like partners instead of a planet and moon. At first, that distant world seemed too cold for surprises. Average temperatures near Pluto can sit around minus 387 degrees Fahrenheit or minus 232 degrees Celsius. Water there acts more like rock than liquid, and nitrogen and methane can freeze into frost across the ground. If you judge Pluto by distance alone, you expect a frozen, sleepy world with not much going on except slow-motion weather. But even before spacecraft arrived, scientists knew Pluto had one big trick. It has a thin atmosphere, mostly nitrogen, with methane and carbon monoxide mixed in. That matters because when Pluto gets closer to the Sun, some of the ice on the ground turns straight into gas. Instead of melting into liquid first, it jumps from solid to gas, builds a fragile atmosphere, and wraps the world in a faint shell of air. That alone was odd enough because Pluto is tiny and its gravity is weak. Its gravity is only about 6% of Earth's, so its air can spread very high above the surface. Experts expected this atmosphere to swell when Pluto moved closer to the Sun and then slowly shrink again as Pluto moved away. That sounded simple, neat, and normal, which is exactly why Pluto was about to ruin the whole picture. The turning point came on July 14, 2015. That was the day NASA's New Horizons spacecraft raced past Pluto, flying only about 4,800 miles above its surface. For the first time, humanity saw this world up close, and almost everything about it felt alive. There were mountains of water ice, smooth plains of frozen nitrogen, strange textures, signs of moving ice, and a huge bright region shaped like a heart. Then came the part that changed this story forever. New Horizons looked through Pluto's atmosphere and found layer after layer of blue haze stacked high above the surface. This was not a thin blur hugging the ground. It rose upward in delicate bands, reaching huge heights into the sky. Suddenly, Pluto stopped looking like a dead ice ball and started looking like a place with weather, chemistry, motion, and secrets. And then the numbers got weird. Scientists expected methane in Pluto's atmosphere to warm the air, at least to a certain level, because methane can trap heat. That is the same broad idea people know from greenhouse gases, though Pluto's world is nothing like Earth's. But the real temperature of Pluto's upper atmosphere came in far colder than expected, around minus 203 degrees Celsius in key layers, roughly 30 degrees colder than many models predicted. That gap mattered more than it sounds. A wrong temperature is not just a bad number on a chart. Temperature controls how gases move, how fast air escapes into space, how frost shifts across the ground, and even how long the atmosphere can survive. If scientists could not explain Pluto's cold sky, then they did not truly understand Pluto at all. Some people first look for a gas that might be acting like a hidden coolant. Water vapor was one idea, because on some worlds gas molecules can help carry heat away. But Pluto is so cold that the needed amount of water vapor would have been wildly unrealistic. The math did not fit, the chemistry did not fit, and the mystery stayed right where it was, staring back. Here's the question I want to throw at you right now. Did you expect tiny haze particles, not big storms or giant oceans, to become the key to a whole planet's climate? If that surprise hits you too, like the video, subscribe, and tell me what you thought the answer would be. This is where one bold idea entered the story. After New Horizons, a scientist named Shi Zhang at the University of California, Santa Cruz looked at Pluto's haze and wondered if everyone was focusing on the wrong thing. Maybe the gases were not the main actors at all. Maybe those tiny floating particles were doing most of the real work, heating up and cooling down so strongly that they were controlling Pluto's whole energy balance. At first, that sounded almost too weird to be true. On Earth, when we talk about air temperature, we usually think about gases doing the heavy lifting. Nitrogen, oxygen, carbon dioxide, water vapor, those are the parts we expect to shape how heat moves. But Pluto may not play by that rule, because its atmosphere is so thin and its haze is so important that the particles themselves can dominate the process. So what is this haze, really? It forms when sunlight hits methane and nitrogen high in Pluto's atmosphere and breaks those molecules apart. The pieces then join into more complex carbon-rich material, creating tiny solid particles that drift through the sky. That is chemistry in motion, and it gives Pluto its strange blue haze, a soft glow built from frozen and organic bits suspended in very cold air. Now comes the twist that makes the whole mystery click. Scientists originally expected the gas to set the temperature, with methane adding warmth and other effects balancing it out. What Zhang proposed was the opposite kind of picture. The haze particles soak up sunlight, then lose that energy by giving off invisible heat light back into space. In simple words, Pluto's sky may be filled with countless tiny pieces of dust-like material that act less like a blanket and more like millions of tiny cooling fins. That idea came with a clear test. If the haze was truly doing this, Pluto should shine in a special kind of invisible light called mid-infrared. That is heat light, the kind our eyes cannot see but sensitive instruments can detect. And not just a little bit. Pluto should be much brighter in that heat glow than older models had expected, bright enough for a powerful future telescope to finally catch. For years, that prediction sat there waiting. Then, on Christmas Day in 2021, the James Webb Space Telescope launched into space. Webb was built to see faint things in infrared light, which makes it perfect for cold, distant objects that do not glow much in visible light. In other words, the exact telescope needed to test this wild Pluto idea finally existed. Webb is not just a better camera, it is more like a heat detective working in the dark. One of its tools, called MIRI, can study mid-infrared light, which lets scientists separate different kinds of heat and chemical signals. That matters because Pluto is tiny, dim, far away, and close to Charon on the sky, so earlier instruments struggled to tease out what belonged to which world. Then came the observation that changed the mystery into evidence. In May 2023, Webb used MIRI to collect a strong spectrum of Pluto from about 4.9 to 27 microns. That range had never really been opened up this well for Pluto before. It meant scientists could read light from the surface, the atmosphere, the gases, and the haze itself, all mixed together, then carefully pull the pieces apart. Webb also watched Pluto and Charon over time as they rotated. These changing heat patterns are called light curves, but the plain idea is simple. Different areas turn toward Webb and give off slightly different amounts of heat. By watching that rise and fall, scientists can test how fast surfaces warm and cool. That helps them learn about thermal inertia, which is just a fancy way of saying how stubborn a place is about changing temperature. Then, the smoking gun showed up. The haze was not hiding anymore. Webb saw clear haze emission in the mid-infrared, especially across a band from about 13 to 20 microns. That means the haze was not just sitting there looking pretty in blue sunlight. It was actively radiating energy away, exactly the kind of behavior Zhang's idea said should exist if haze particles were controlling Pluto's temperature. That is why this result matters so much. Webb did not just take a new picture of Pluto, it confirmed that a strange prediction from 2017 was real. Pluto's atmosphere seems to be controlled mainly by haze particles, not by gases alone. As far as scientists know, that makes Pluto different from every other major atmosphere in our solar system, and the story gets wider from there. Saturn's moon Titan has a thick, hazy atmosphere. Neptune's moon Triton has a nitrogen atmosphere with haze too. If haze can shape Pluto's climate this strongly, then scientists may need to rethink how haze works on those worlds as well, especially in very cold places where tiny particles may matter far more than expected. Let me pause here and ask you something. If a world this small can rewrite what we thought atmospheres do, what other rule do you think is waiting to break next? Drop your guess in the comments, and if you like real science with the drama left in, subscribe and stay with me. Now we can return to the title question. Why does Pluto refuse to warm up? Because what should have acted like a gentle heating system is being undercut by a built-in cooling machine floating in the sky. The haze absorbs energy, yes, but then it throws that energy back out into space as heat light, which keeps the atmosphere colder than many scientists once believed possible. That does not mean Pluto never changes. It does. Pluto still has seasons, and they are wild because its orbit is stretched out and tilted. From 1979 to 1999, Pluto was actually closer to the Sun than Neptune, and that extra sunlight affected its surface ice and atmosphere. But even with those changes, the deeper lesson remains that Pluto's climate is not being ruled in the ordinary way people first expected. And there is another layer to this puzzle. When scientists say Pluto is not warming up, they do not mean every inch of Pluto stays frozen at one fixed number forever. They mean the atmosphere, especially high up, is much colder than standard gas-based models said it should be. That difference shapes everything, from escape into space to pressure changes to where ice gathers and where it leaves. New Horizons had already shown that Pluto's surface and air are linked by moving ice. Nitrogen and methane can freeze, sublimate, drift, and settle again in a slow global cycle. Webb now adds a stronger clue about why that cycle behaves the way it does. If the atmosphere loses heat through haze more efficiently than expected, then the whole exchange between surface and sky has to be understood in a colder, stranger way. There is even a ghostly side story happening beside Pluto. Some methane escapes from Pluto's atmosphere and can end up at the poles of Charon. There, it may get changed by radiation into darker reddish material, helping stain Charon's polar regions. So Pluto is not only managing its own bizarre climate, it is also quietly dusting its biggest moon with borrowed chemistry. That is one reason the Pluto-Charon system feels less like a static pair of rocks and more like an active relationship. Pluto has air, Charon mostly does not. Pluto has moving volatile ice, which means ices that can easily change from solid to gas. Charon can catch some of what Pluto loses, turning one world's leaking atmosphere into another world's surface markings, in a process that feels almost impossible until you remember space has had billions of years to work. Now step back and look at how unusual Pluto really is. It is tiny, freezing, and dim. Its atmosphere is thin, yet it stretches very high. Its haze is delicate, yet it seems to control the climate. Its moon is huge compared with it, and the two worlds trade material in a way we do not see anywhere else in the solar system. What Webb found also helps explain why older predictions missed the mark. Those models were not foolish. They were working with the best-known physics and the data available at the time. But Pluto was hiding a major player in plain sight. The blue haze that looked like a beautiful detail in images turned out to be a physical force, one strong enough to steer the whole thermal story. This is the moment where the story shifts from what happened to what is still happening now. Right now, Pluto is still moving through its long orbit. Right now, its surface ices are still responding to sunlight over seasons that last for decades. And right now, scientists are using Webb data to refine their models, because now they know the haze is not decoration, it is machinery. Webb did more than confirm the cooling idea. Its spectrum also showed that Pluto's atmosphere is chemically rich in ways that help tell the haze story. Scientists saw strong signs of gases like ethane, acetylene, methylacetylene, and diacetylene. Those names sound heavy, but the simple part is this. Pluto's air is making and carrying more complex carbon-based molecules than a quick glance would ever suggest. That matters because haze does not come from nowhere. It grows out of chemistry. Sunlight breaks apart simple gases like methane, and the fragments build more complex material over time. Some of that stays as gas, some of it can become part of the haze itself. So when Webb sees rich chemistry and sees haze glowing in heat light, those two clues fit together like parts of the same machine. Scientists also found that Pluto's haze does not seem to behave exactly like Titan's haze. That is important because it means even hazy worlds may not all follow one recipe. Pluto's version may contain different organic ices or different particle properties, which changes how it absorbs and gives off energy. In simple terms, Pluto may not just be another hazy world, it may be a special class of hazy world. There is a deeper reason researchers care about that. Long before Earth had oxygen in its atmosphere, life already existed here. Back then, Earth's air was mostly nitrogen with a lot more hydrocarbon chemistry than we have now. Scientists are careful with comparisons, but Pluto's nitrogen and hydrocarbon haze could still help them think about how complex chemistry behaves in very different worlds, including worlds from Earth's own deep past. So no, Pluto is not a stand-in for ancient Earth. It is far colder, far darker, and far more extreme. But it can still act like a natural experiment, a place where chemistry and climate mix under conditions we cannot build at full scale on Earth. Sometimes the outer solar system tells us about our own planet by being nothing like it. I want to ask you something before we go further. When you hear that a frozen dwarf planet might help us think about Earth, Titan, and even distant exoplanets, does that make Pluto feel bigger to you? If it does, leave a like, subscribe, and tell me when Pluto stopped feeling small in your mind. To really feel how strange this is, compare Pluto with the climate story most people know on Earth. Here, greenhouse gases often trap heat and make the lower atmosphere warmer. On Pluto, methane can still warm some layers, but the haze seems to step in and dump energy away so effectively that the net result stays far colder than expected. It is like building a house with a heater running, only to find that the walls are made of material that glows your warmth straight back into the night. And that changes more than one planet's weather report. Astronomers are finding worlds around other stars all the time. Many of those worlds may have hazes, thin atmospheres, thick atmospheres, exotic chemistry, or all three. If tiny particles can reshape a planet's temperature this strongly, then every time we see a hazy distant world, we may have to ask a harder question. Is that haze trapping heat, or is it letting the world bleed heat away? This is why Webb matters so much here. Pluto is incredibly far, incredibly faint, and still Webb pulled a climate answer out of the darkness. That is not just a win for one telescope. It is proof that we are entering a time when distant worlds in our own solar system can be studied with a level of detail that once belonged only to planets much closer to home. It also reminds me of something people forget. Science is not only about collecting facts, it is about being wrong in useful ways until nature finally shows you the better answer. Scientists expected one thing from Pluto's atmosphere. Pluto answered with blue haze, missing heat, and a lesson that a tiny world can still surprise a giant field. Xi Zhang once called the haze idea a crazy one. That line matters because it shows how science often moves. A strange guess is made, many people doubt it, a prediction is written down, and then years later a machine powerful enough to test it finally arrives. When that prediction survives contact with reality, the story changes from theory to discovery. And yet the case is not closed. Scientists still want to learn exactly what the haze particles are made of, how large they are, and how their properties change from one altitude to another. They want to know how surface ice, seasonal sunlight, and atmospheric chemistry keep feeding one another over long Pluto years. And they want to test whether similar hidden cooling is shaping other cold, hazy worlds beyond Pluto. That means Pluto is not done giving answers or causing trouble. Each new observation sharpens one mystery and often opens two more. How stable is the atmosphere over decades? How fast does material escape? How much does Charon collect? How many of Pluto's strange rules are truly unique, and how many are waiting to be found somewhere else? The emotional weight of this story is simple, and I think that is why it stays with me. The farther we look, the more we find worlds that do not behave the way our neat categories say they should. Pluto was called too small, too cold, too distant, too minor. And now that same world is forcing scientists to rethink how a planetary atmosphere can work at all. So when people ask why Pluto refuses to warm up, the answer is no longer a shrug. It is a real physical story, written in haze, chemistry, infrared light, and a telescope a million miles from Earth. Pluto is cold not just because it is far from the sun, but because its strange sky seems built to shed heat in a way we had never clearly confirmed before. That is not a boring answer. That is a new rule found at the edge of the solar system, and maybe that is the part I love most. A world once treated like a footnote has become a teacher. A dim point found in 1930, then demoted, argued over, joked about, and misunderstood, is now telling us that even tiny particles in thin air can control the fate of an entire climate. That is the kind of twist space gives us when we keep looking longer than our pride wants to. Before we end, I want to hear your take. Did James Webb's Pluto result make you think more about alien weather, ancient Earth, or just how weird our own solar system still is? Subscribe, turn on notifications, leave your answer in the comments, and share this with someone who still thinks Pluto is just a frozen rock. Thanks for watching. Thanks for being curious with me. I will see you in the next one.